Okay, good day everyone. Our learning competencies for quarter 1 week 4.1 is to determine geometric means and the nth term of a geometric sequence. Once again, I am Gerardo T. Biduya, teacher of Ordineta City National High School. Now, let us recall first your exponent. Exponent is a numerical that tells how many times the base is used as a factor. For example, in number 1, a raised to 3, where a here is the base and 3 is the exponent. So we'll have to multiply a 3 times by itself. So we have a times a times a. Number 2, 3 raised to 4. 3 is the base and 4 is the exponent. So we will multiply 3 4 times by itself. So we have 3 times 3 times 3 times 3 is equal to 81. Number 3, we have 7 raised to 3. So it is equal to 7 times 7 times 7 is equal to 243. Number 4, 5 raised to 0. We have the rule in the laws of exponent that any number raised to 0 power is equal to 1. So 5 raised to 0 is equal to 1. Number 5, 81 raised to 0 is equal to 1. Number 6, the quantity negative 9 raised to 0 is equal to number 7. Negative 25 raised to 0 is equal to negative multiplied by the quantity 25 raised to 0 is equal to 1. Therefore, negative times 1 is equal to negative 1. Next, we have now the formula of a geometric sequence, which is a sub n is equal to a sub 1 multiplied by r raised to n minus 1, where a sub n is the last term, a sub 1 is the first term, r is the common ratio, and n is the number of terms. Okay, for example, given a geometric sequence 2, negative 6, 18, negative 54, and so on, find the ninth term of a sequence. First, we have your given. The first term is equal to 2. The n number of terms is equal to 9 because we are finding the value of a sub 9. R is equal to, dividing the second term by the first term, we have negative 6 divided by 2 is equal to negative 3. Therefore, the ratio is negative 3. Then, your required is a sub 9 or the ninth term. Then, using your equation, a sub n is equal to a sub 1 r raised to n minus 1. That is your geometric sequence formula. Then by substituting the value of n, we have now a sub 9 is equal to 2 a sub 1 multiplied by the ratio negative 3 is raised to 9 minus 1. So by simplifying, 2 multiplied by negative 3 raised to 8, where negative 3 raised to 8 is equal to 6,561 multiplied by 2, then we have a sub 9 is equal to 13,120. 22. Next, we have your geometric means. Geometric means are the term between any two given terms of a geometric sequence, or more specifically, mean proportional. If a sub 2 is the mean proportional between a sub 1 and a sub 3, then by definition of a geometric sequence and by the ratio of your of the mean proportion is equal to a sub 2 divided by a sub 1 is equal to a sub 3 divided by a sub 2. So by cross multiplication, we have now a sub 2 times a sub 2 is equal to a sub 1 multiplied by a sub 3 is equal now to a sub 2 raised to 2 is equal to a sub 1 multiplied by a sub. Then let us extract the square root of a sub 2 raised to 2 is equal to positive and negative square root of a sub 1 times a sub 3. Then we have now a sub 2 is equal to positive and negative square root of a sub 1 times a sub 2. Therefore, the mean proportion between two numbers is equal to the square root of their products. Okay. For example, find the geometric mean of 9 and 16. So here, using your mean proportion, which is a sub 2, is equal to positive and negative square root of a sub 1 times a sub 3. So by substituting the value of a sub 1 and a sub 3, we have 9 times 16. So we have 144. So a sub 2 now is equal to the square root of 144 is equal to 12. So our answer here is positive. And a sub 2 is equal to 12, which is now your geometric mean. Okay, we have now your activity 1, direction. Given the explicit formula for a geometric sequence, find the first 5 terms and the 8 terms of a geometric sequence. Okay, number 1, our explicit formula is a sub n is equal to n raised to n minus 1. So here, let us assign the value of n from 1, 2, 3, 4, 5. So, if n is equal to 1, so we have now to substitute the value of n, which is now a sub 1, the first term, is equal to 2 raised to 1 minus 1. And therefore, 2 raised to 0. So, in your laws of exponent, any number raised to 0 is equal to 1. So, the first term is equal to 1. Okay, when n is equal to 2, then we have a sub 2 is equal to 2 raised to 2 minus 1. 2 minus 1 is 1. Therefore, a sub 2 is equal to 2. When n is 3, we have now a sub 3 is equal to 2 raised to 3 minus 1. 3 minus 1 is equal to 2. Then a sub 3 is equal to 4. When n is 4, we have a sub 4 is equal to 2 raised to 4 minus 1. Then we have 2 raised to 3. Then a sub 4 is equal to 8. When n is 5, we have a sub 5 is equal to 2 raised to 5 minus 1. a sub 5 now is equal to 16. When n is 8 now, we have a sub 8 is equal to 2 raised to 8 minus 1. Then 2 raised to 8 minus 1 is 7. Then 2 raised to 7 is equal to 128. Then a sub 8 is equal to 128. Therefore, the first 5 terms are 1, 2, 4, 8, and 16. And the eighth term is equal to 128. Okay, activity 2, 3 and 1, direction. Given the recursive formula for a geometric sequence, find the common ratio, the first 5 terms, and the explicit formula. Example number 1, a sub n is equal to a sub n minus 1 multiplied by negative 2. And a sub n minus 1 is equal to negative 2. So you have your given where n is equal to 1, a sub 1 is equal to negative 2, r is equal to negative 2. So using your geometric sequence formula, we have now your a sub n is equal to a sub 1 multiplied by r raised to n minus 1. So by substituting the value of n, a sub 1, and the ratio, we have now a sub 1 is equal to negative 2 multiplied by the quantity negative 2 raised to 1 minus 1. So by simplifying, negative 2 multiplied by negative 2 raised to 0. So we have now negative 2 multiplied by the quantity 1. So we have now negative 2. Next, when n is equal to 2 and r is also negative 2. So your equation a sub n is equal to a sub 1 multiplied by r raised to n minus 1. So by substituting the value of n, a sub 1 and r, so we have a sub 2 is equal to negative 2 multiplied by the quantity negative 2 raised to 2 minus 1. By simplification, negative 2 multiplied by negative 2 raised to 2 minus 1 is 1. So we have now negative 2 times negative 2. So a sub 2 is equal to positive 4. When n is equal to 3, your a sub 1 is negative 2 and r is negative 2. So using your equation and by substituting the values, we have a sub 3 is equal to negative 2 multiplied by the quantity negative 2 raised to 3 minus 1. So we have negative 2 multiplied by the quantity negative 2 raised to 2. So negative 2 multiplied by negative 2 raised to 2 is positive 4. So a sub 3 is equal to negative 8. When n is 4, a sub 1 is equal to negative 2, r is equal to negative 2. So using your equation, then by substituting the value of n, a sub 1 and r, so we have a sub 4 is equal to negative 2 multiplied by the quantity negative 2 raised to 4 minus 1. By simplifying, negative 2 multiplied by negative 2 raised to 4 minus 1 is equal to 3. Then negative 2 multiplied by negative 2 times negative 2 times negative 2 is negative 8. So a sub 4 is equal to positive 16. Next, when n is 5, a sub 1 is negative 2, and r is negative 2. So using your equation and by substituting the values, we have a sub 5 is equal to negative 2 multiplied by the quantity negative 2 raised to 5 minus 1. So we have now negative 2 multiplied by negative 2. 5 minus 1 is equal to 4. So negative 2 multiplied by negative 2 raised to 4 is equal to 16. Then a sub 5 is equal to negative 30. Then your first 5 terms of the geometric sequence is negative 2, 4, negative 8, 16, and negative 32. Your explicit formula is a sub n is equal to negative 2 multiplied by negative 2 raised to n minus 1. Okay, let us go on. Activity 3. Direction. Insert geometric means in the following geometric sequence. For example, letter A, 3, then blank, 27. So here, we'll have to use your mean proportion. The mean proportion between two numbers is equal to the square root of their product. So therefore, we have to use now your a sub 2 is equal to positive negative square root of a sub 1 multiplied by a sub 3. So by substituting the values of a sub 1 and a sub 3, we have 3 times 27 is equal to the square root of 81. The square root of 81 is equal to positive negative 9. Then the value is equal to positive 9. We'll have to use your positive. Letter B. We have your geometric sequence. We have 2, the missing 2 terms, and the last term. So you have the given, the first term is equal to 2. The last term is 54. Your n is equal to 4 because there are 2 given terms and 2 missing terms. So we have 1, 2, 3, 4. Then you have to find the value of the common ratio. So in this problem, we'll have to use your geometric sequence formula, which is a sub n is equal to a sub 1 multiplied by r raised to n minus 1. Let us now substitute the values of a sub n is equal to 54. The value of a sub 1, which is equal to 2, r is the unknown, so we have r raised to 4, the value of n minus 1. Then we have now 54 is equal to 2 times r, 4 minus 1 is equal to 3. Now to eliminate the value of 2, we'll have to divide both sides of the equation by 2. So 54 divided by 2, 27. 2 divided by 2 is now equal to r cubed. Then let us extract the square root of both sides of the equation. We have the cube root of 27 is equal to the cube root of r cubed. So you have now 3 is equal now to the cube root of r cubed is equal to r. Therefore, the common ratio is equal to. Okay, to find now the second term, we have to multiply the first term by the common ratio. So we have 2 times 3 is equal to 6. Then the second term, 6 times the common ratio is equal to 18. Then therefore, the geometric means are 6 and 18. Then you have now your geometric sequence 2, 6, 18, and 54. Next, letter C. You have 4 missing terms. And the given here are the first term, which is 81. Your n is 6 because there are two given terms, 81 and 1/3, and 4 missing terms. So we have 1, 2, 3, 4, 5, 6. Your last term is equal to 1/3, and the ratio is the unknown. So using your geometric sequence formula, a sub n is equal to a sub 1 multiplied by r raised to n minus 1. Then by substituting the values of a sub n is equal to 1/3, your a sub 1 is equal to 81 multiplied by r 6 times, or I mean 6 minus 1. Therefore, we have 1/3 is equal to 81 multiplied by r raised to the fifth. So here, we'll have to eliminate 81 by dividing both sides by 81. So we have now 1/3 times 1 over 81 is equal to r raised to 5. Then therefore, we have 1 over 243 is equal to r raised to 5. So here, we'll have to extract the fifth root of the 2. So we have the fifth root of 1 over 243 is equal to the fifth root of r raised to 5. So we have now 1/3 is equal to the fifth root of r raised to 5 is r. So okay, we'll have to multiply the ratio to the first term. 81 times 1/3 equals 81 times 1 divided by 3 is 27. Then 27 times the ratio 1/3, 27 times 1 divided by 3 is equal to 9. 9 times 1/3, or 9 times 1 divided by 3 is equal to 3. 3 times 1/3 is equal to 3 times 1 divided by 3 is equal to 1. Then therefore, your geometric means are 27, 9, 3, and 1. Then our geometric sequence, 81, 27, 9, 3, 1, and 1/3. Okay, that ends my lesson. Thank you, and stay tuned for the next virtual instruction.